Good morning and welcome. My name is Hamed Ala Mohammed. I am a postdoctoral associate here in the Department of Civil and Environmental Engineering at MIT. It's my pleasure to welcome you all today to MIT on behalf of our host today, the Iranian Studies Group. Also a warm welcome to our online participants from around the globe who are joining us today over WebEx. We are here for the second day of the workshop on the future of Urmia Lake, named Can Water Diplomacy Enable a New Future for the Urmia Lake? This two-day workshop wouldn't be possible without the support of our three main organizers, the Water Diplomacy Program, the TUFTS Institute of Environment, and the Iranian Studies Group at MIT. I would also like to thank our scientific sponsors, namely the Geological Survey of Iran, MIT Water Club, UNDP, University of Tabriz, Urmia Lake Restoration Program, and the Water Engineering Research Institute of the Tarbiyat Modarres University in Iran. Yesterday we had very successful and in-depth panel discussions about different aspects of Urmia Lake Restoration Program. And I believe we touched upon very important aspects of the problem and tried to open up different issues with that. Today we are going to continue that by focusing more on the socioeconomic challenges that are facing the restoration program. The same as yesterday, please use the hashtag Urmia Lake for your tweets about this event today. You may also use the @Urmia Lake account to tweet to us during the meeting with any questions. Before introducing our first speaker, I would like to take a moment to introduce to you our host today at MIT, the Iranian Studies Group, or ISG. ISG is a nonpartisan, nonprofit, and academic organization with the aim of promoting Iranian civil society through conducting research on issues related to the Iranian native and expatriate societies. Our activities include organizing talks and seminars here at MIT, as well as conducting research on an array of topics. Our research projects focus on the cultural, social, economic, and political development of the Iranian society. By actively publicizing our findings in a format that is accessible for the community at large, we aim to bridge the gap between research, public knowledge, and policymaking. So our next speaker is Dr. Asghar Asghari Muqaddam, who is going to talk about the impacts of groundwater abstraction on Urmia Lake and the challenges of the illegal wells. Dr. Muqaddam is a professor of hydrogeology in the Department of Geology at the University of Tabriz in Iran, again from the region and very familiar with the basin. Dr. Muqaddam, please.
Good morning, everybody. The topic of my speech is impact of groundwater abstraction on Urmia Lake and challenges of illegal wells. I'm looking from hydrogeological point of view. Most people think as hydrologists, so the view is a little bit different. Outline of the presentation are just brief description of Urmia Lake Basin, including physical subdivision of the basin, plains of the basin, main project in the basin, main water project in the basin. Interaction between surface runoff and groundwater, surface runoff regulation by constructed dams, groundwater overdraft from the aquifers, geology of the area, interaction of the adjacent aquifers and the lake, conceptual model of water cycle in the Urmia Lake Basin, saline water intrusion into freshwater aquifer, and summary and conclusion. This figure shows physical subdivision of the basin. There are 14 rivers crossing the plains. Some of them one plain, some two or some three plains. The main rivers are Ajichai River, Zarinerut River, Siminerut River, Kadarchai, and Zolachai. Urmia Lake is a closed basin with 51,876 square kilometers. The most important water project in the Urmia Lake basin from Hassanzadeh et al. 2012, having constructed dams on the main rivers, prevent from flooding rivers, and reserve or regulate water of the rivers. The regulated water of the rivers loses their water into the groundwater or using directly by the farmer. The figure shows the name of plains with their sector areas name. There are 25 small and vast plains in the area, the rivers crossing the plains, and in each plains we have one or two aquifers, maybe confined or unconfined aquifers. This is a figure shows groundwater and surface water and groundwater interaction. This figure is a core of my speech and core of my what I am going to say. Figure A is a giving river or influent river. The water level, the groundwater level is higher than the water level in the river. Therefore, the river is a gaining river. And it gets water from the aquifer, and you know the area is green area because the water level is high and the roots of the vegetables can reach the groundwater. The second figure, or figure B, is a losing river because the groundwater level is lower than the water level in the river. But the groundwater is not too much low, so some even near the river we have vegetation. But the water level in the aquifer is lower than the water level in the river. Therefore, river in its root lose the water. In figure C, the water level in the aquifer is too low. So even in a small river on a tributaries where the river is losing river. So the water in the river loses or water during the passage. And in the Urmia Lake Basin, we have this situation. The situation I think we have in Urmia Lake Basin. This is a 3 monthly moving average river discharge from Buchan Station in Siminerut. You can water level decreases during the time. And this is the groundwater level from Buchan Plain aquifer. The decreasing water level in the aquifer coincides with decreasing water level in the water discharge in the river. This figure is showing 3-year moving average in cubics from the Ajichai River, cubic meter per second. Water discharge here is about 15 cubics. In the end, 2011, it's about 5 or less than 5. The discharge of rivers decreased during this 10-20 years about from 15 to 5 or less than 5 cubic. This is the problem. We have the basin. The river water reduces day by day. And in my opinion, it is because of reducing the groundwater level or abstraction from the aquifers more than renewable water. This shows the water level in the Urmia Lake. I'm passing from this. This figure shows the water level for the 3 lakes. We're comparing 3 lakes water level, which more or less they have the same climate. This is Saiwan Lake. The distance between these 3 lakes is less than 500 kilometers. Saiwan Lake increasing. 1 lake more or less constant. Urmia Lake decreasing. Urmia Lake decreasing sharply. This shows this is the problem caused by man-made. And the effect of the climate is, in my opinion, very low. This is the Urmia Lake from past to present. This figure shows the distribution of shallow and deep well in Urmia Lake Basin. Green color is for East Azerbaijan, red color for West Azerbaijan, and this color for the Kurdistan area. In the past, the upstream of the basin, there was no well. The people used from the surface water. Some wells we had only in the downstream, but nowadays, upstream, there are a lot of wells. One river is losing in downstream and gaining in upstream. But nowadays, all the rivers are losing river because we have an upstream also wells. There is more than 88,000 wells, some of them illegal, and some authorized. But we don't know exactly this data is right or because the owners never say, I have a well. This is the detail of the wells, deep well, shallow well, and abstraction rate from there, as well as canots and springs. This is the shallow well and discharging rate from the shallow well, and the number of shallow wells, deep wells, discharging rate, and number of deep wells, springs, discharging rate, and number of springs, canot, discharging from the canot, and number of canots. Total abstraction from the aquifers are about 2 billion cubic meters per year. This is the lithological map of the Urmia Lake Basin. Unfortunately, we have Miocene formation series in this area. Miocene formation has salt dune, conglomerate, and some other formation. So the water originates from this area is saline and high discharge is charged by small material, fine material, such as silt and clay. So around the lake, because of low gradient and because of geological conditions, we have very fine material. And water comes from the Ajita is more or less saline. This is the geological map of the Tabriz area. These two cross sections, especially this one, it starts from Azashar, across the Tabriz plain, it's to Shabstar. And I'm going to show this cross section and think about the interaction between aquifers and the lake. We have interaction between surface water and groundwater, but we haven't got interaction between aquifers and the lake. This is the cross sections we have. You see, this is the end of the plain, which is silt and clay. Total of the well showing the well logs, showing the material as the silt and clay. This is also location of geological cross section and soundage from Azar Shah plain, and I'm going to show cross section 25, 22, 24. This is the cross section 22, and this side is the lake side. This one is the old lake formation or old lake sediments, and these sediments are silt and clay. Therefore, there is no connection between the lake and the aquifer in this spot also. Cross section 24, so this side is the lake side, shows the silt and clay containing salt. After this, I'm going to talk about the salinity in the aquifer. Some salinity comes from this formation, salt and clay, silt and clay with salt or containing salt. This one also, the old lake sediment as the salt. So upconing from this formation made the aquifer saline. This is cross-section 25. Just you see this part, then silt and clay with containing salt, and this one, connate water, old old lake sediment. This is a map of Shabstar Plain. This is the Shabstar aquifer. This is lake. This is the aquifer. You can see well 12, 11, 9, 8, 5, 4, and I'm going to show the log of this well in next section, next slide. This is the log of this well. They are all fine material. It says there is no connection between the lake and the aquifer. Then connection between lake and aquifer, or lack of this connection, is very, very important. Because if you put water in the lake, if there is a connection, maybe it throws to the aquifer. Lack of connection, there is no continuity between these two, and there is no problem having high level in one of them. It's a conceptual model for incomplete water cycle in Urmia Lake. Why there is no water in Urmia Lake? Because this is the river, or one of 14 rivers crossing the plain. We have a dam. We reserve the water behind the dam, regulate it. Farmers using from regulated water, and some of them infiltrate to the aquifer without reaching the lake. And again, we pumping from the aquifer and using it, and again, some of it infiltrates the aquifer. We have a cycle, incomplete cycle in inland between the surface water and groundwater, excluding the lake from this cycle, this water cycle. This is the Azashar plain I'm looking at as an example. This is the groundwater flow direction. You see in end of the plain and end of the aquifer, there are rivers flow. And the saline water from the salty, silty, and clayey materials comes to the aquifer and make the aquifer saline. This is the main problem in the area, even worse than the Urmia Lake. There is 14 aquifers around the lake, very agriculturally active plains, so they are getting saline water. So I'm showing the, this is the salinity in the Azashar plain aquifer. 9,000 microsieverts per centimeter, 8,000, 70,000, 10,000, more than 4,000, not even for the agriculture. See what happens for our aquifer. The situation is very, very worse than the lake. This one shows the water level in the Azar Shahr aquifer. Water level in this time reduces, such as the Urmia lake. But after that, the groundwater level not reduces. Why? Because we have saline water. The people cannot use that. And the measuring the water level, measuring the water level, they don't change. They are the same. So it shows the average long-term water level, such as this is average electrical conductivity variation in the Azar Shahr lake. During the 15 years, or maybe 20 years, less than 20 years, it increases from 1,400 to 2,400. More than 1,000 micromoles per centimeter is increased. Conclusion and summary. Long-term average rainfall in the basin is about 316.1 millimeter, which produces about 1.5 times 10 to 10 cubic meter water. Before highly groundwater development stage in the basin, about 5.6 times 10 to 9 cubic meter of this water were reached to the lake, but nowadays only 1.7 times 10 to 9 cubic meter as the runoff reaches the final hydrometric gauge stations of the rivers, which may be only a small part of this to reach the lake, because final station is far from the lake. It's not the entrance of the lake. It is far from the lake. A lot of water will losing after this gauge station in a buffer zone. It's a buffer zone. The zone between the lake and the aquifer. Lake's water level in 1995 to be at its highest level of any time in the past 40 years, but it shows a drop of about 8 meters between 1995 and 2014. There are 14 main rivers which drainage the runoffs to the lake. The amount of discharging from the rivers have been reduced remarkably during the past 15 years. The upper red formation, or Miocene series, is widely exposed in the northeastern part of the Tabriz area, made up of red malt with gypsum, conglomerate, salt, and marly limestones with thickness of up to 1,000 meters. Ajachai River and some of its sub-branches crosses these series. Therefore, the water quality of the river is saline and abundantly charged with suspended material. Groundwater resources of the basin withdrawn by 72,227 shallow and 8,056 deep wells, 1,060 springs, and 1,592 canals. total groundwater withdrawn from the basin is more than 2 billion cubic meters per year. Declining of groundwater levels in aquifers causes that the all rainfall, which their intensity is less than the infiltration velocity to infiltrate the aquifer, and the all rivers crossing the aquifer being as a losing river. Having constructed dams on the main rivers prevent from flooding rivers and reserve or regulate water of the river. The regulated water of the rivers loses their water into the groundwater, and during the irrigation period pumped out by the farmer. This water cycle in the land continues and prevent from the reaching of surface and groundwater to the lake. There are very fine grained sediments such as silt and clay particles between the lake and the adjacent aquifers. Therefore, hydraulic connections between the aquifers and the lake can be very poor. The higher values of salinity in those parts of the aquifers near to the lakes is resulting from flatness of the ground surface and very low velocity of the groundwater, shallow depths of groundwater and high evaporation, a boundary of silt and clay at the outlet of groundwater flow from the aquifer, leakage of saline water from some saline water rivers, and intrusion of saline water to the freshwater parts of the aquifer and upcouling of saline water. Interrupted in sediment in deeper section of the aquifer due to highly groundwater abstraction and declining of groundwater level. Thank you.
Thank you, Dr. Mogaddam, for the very informative talk on the groundwater issues and the geography of the region. If I want to give a very short summary of the 4 presentations we had from the Iranian delegation. So we had the very top-level introduction from Dr. Morid yesterday, talking about the basin, the challenges, the tourism industry, the background, and what has happened before, and the modeling they have done. Dr. Lack gave a presentation about the paleoclimate, how they have studied the sediment, the cores, and what they have found based on that, what is happening in the basin. This morning we started more going under the ground, what's happening with the groundwater, what we know about the groundwater, what will happen if we add water to the lake, does it stay there or does it go away, and what is happening to the rivers and the upstream, what are the farmers doing. I mean, mostly physical and the characteristics of the basin. And also, Dr. Zainalzadeh giving presentation both on the groundwater and the plans that the Urmia Lake Restoration Program has put together, and the projects they are following up, and if they are meaningful or not. So, giving that summary, I wanted to say we have enough food now to start the discussion and going over those projects and the questions we raised yesterday, and the questions and problems that Dr. Zainalzadeh put at the end of his presentations, and see if they are doing well or not. I mean, what we think about them. So, if you have any questions from the presentations of this morning, let's go over them first. We have something like 10 minutes before having the break, and then going out for a break, and then coming back with the discussion time, and also a presentation from Dr. Hamid Quddusi over Webex. So if you have any specific questions for the presenters or about the content of this among ourselves, please share it now. Yeah, please.
Do you observe any subsidence from overpumping in the confined aquifer? And my second question has to do with the connection between the social and the hydrology, I guess. You said that originally all water was supplied by the canal. When that changed, do the canal still get there that allows for the maintenance of the, and so the pumping, the wells are in addition to the subsidence. So for the non-geoscientists, it's the same problem as in California. Once you observe subsidence, the reconstruction of the aquifer is difficult because the sediment basically collapses, pore space disappears. So once you take the water out of the pore space, the sediment collapses, and then it will be very difficult to restore it.
About the canals, maybe more than half the canals are working now. So some canals, they are in the upstream, is working, reducing the waters of some of them, and maintenance of this is shared for example, for one village, they are shared for the canals and working them for for maintenance account.
And the reason why they don't carry water, or some of them don't carry water anymore, is because the water levels have gone down?
Yes, water level, the pumping well causes the dropping of the water level, and the canal is not very deep, so they are going to dry.
And for how long was that system of canals in place? I just looked it up. That must have been
Many times.
Thousands, right?
Yeah.
Thousands.
Shafiq?
Thank you very much. This was a very interesting answer. I would like us to go back to the issues of scale that we talked about yesterday. For example, you made one observation, including slide, that there is a 316 millimeter of rainfall that translates to about 15 billion cubic meter of water.
Yeah.
Now, if you look at that is probably correct, but at a scale which is not probably the basin, because in the basin yesterday, Mahdi and I was just posted that it is 7 billion cubic meters. So both are correct probably, but correct at two different scales. The question is really, unless we, and then you said the groundwater abstraction is about 2 billion cubic meters. That is maybe also correct, but that may be coming from another place. They are not connected. Now, if we do not align these scales properly, the mass balance itself is not even correct, because they are correct at particular scale. And these numbers, now you take these numbers and the numbers that I told yesterday, they don't make sense.
Yes.
Then
the climate. Somebody says 56, I'm now.
So here the challenge, I think, for us is to figure out really exactly what scale we're interested in. Am I really interested in the basin, or the lake, or the whole system, or Iran, or the globe? And these are very different questions, and I don't think either of them are right or wrong. If we have to intervene, we need to know really exactly where am I intervening. If I can extract 2 billion cubic meters of water from groundwater, I'll be in a good shape. Because we saw that basically we need only 1 billion to make the water balance right for the lake level. Disconnect unless we resolve ourselves, like as scientists, we cannot go to the politician and tell them that, look, I need more water. So I think the challenge is to first define what that boundary is and where the intervention is.
Yes, I just want to add
Use
that.
the mic.
Yes, sure. Just to make sure about the number 7 I said to you yesterday. 15 is the total precipitation on the basin. But however, we have evaporation from the basin, and the 7 is the net accessible water. I mean, the potential water to be allocated. The 15 billion comes every year as a rain, and you cannot manage that. But 7 is the net that the manager could allocate that water. Yes.
Now you have to be basically more like a dollar. So between 15 and 7, this is basically a very large number, and I could very easily argue that error is at least 20%. Which way I do not know, because even the best measurements of true evaporation side by side cannot agree measurement-wise in plus minus 20%. So if I say that, look, out of this 15, 3 is an error, then I have more water than I need. So then I think the uncertainty of information could be very powerful. So maybe that is the bottleneck.
I think Jim and Bish, I don't know which one of you was first, but
just a quick question for Professor Mogadam. This is a really excellent analysis. Thank you. And one of the big challenges, though, we find in other contexts in the western U.S., and I imagine in Urmia Lake, is the estimation of the groundwater pumping. And how was the groundwater pumping from shallow and deep wells estimated? Because very few of these wells are actually metered or...
Yeah, the abstraction from deep wells is 20 liters per second or 30 liters per second, but from shallow wells, maybe 5 or 6 liters per second.
And so the estimate to get to error questions, what would you say the estimation error is for the groundwater abstraction?
Estimation error from the illegal wells. The estimation error is I think, well, they are illegal or unauthorized. Don't know how much. They are saying 88, but I don't know exactly why for maybe made it very, very more than before. They don't know that.
So the total number of wells is one question, but if one is asking for pumping estimation, we've had the big problem with how do we estimate pumping?
Even this,
Okay, so maybe plus minus what percentage would you say?
but I showed there how much is deep well, how much is deep well, how much is shallow well. I cannot remember the
I remember the table.
data.
Yeah.
Yeah.
That was the number of wells, and also this table.
What can Google?
Just all sense of precision.
This one, the number of shallow wells and abstraction rate is 86,000, yeah? 860,665.4. This is from shallow wells. And the other one is from deep wells, 103. Oh, this is the more.
And what would you say that the error is plus minus what percent? It's the same question.
I don't know how much plus or minus. I don't know.
Sorry, I just want to make one of them. There are two types of problems here. One is that there are scientific uncertainty. Uncertainty that is about related to groundwater that persons that are it does. That's what we do as technology. It may not be relevant. To me, I think this may not be very relevant for the policy implication. Why do I say that? One observation you made, which does not matter whether it's surface, ground, climate change, whatever, is that the lake level has gone down by 8 meters.
Yeah.
That is observable. How did that happen? That is the key question. And what can be done to at least stop it or make it better? That is, I think, the key question here. Now, then you have to dig in deeper, really, where is it coming from? Unless we ask that question, we may get stuck here. Because, as you said, that there are 72,000 aquifer, like groundwater wells. I'm not going to go actually measure all of these 72,000. It may take another 30 years, $100 million, and get a very good estimate of that groundwater abstraction. By that time, lake may be dead. So then the question is, what is the bottleneck? In my mind, the bottleneck is it is going down. We know that.
Yeah.
We have seen that. We have said in last 20 years, it has gone down by 8 meters. Question is, how did it go down? Is it because that agriculture is using more water, or is it something else?
No, because using from ground, in my opinion, because I am a hydrogeologist, I am, in my view, all the problems from the groundwater. But maybe Dr. Moore or other hydrogeologists, they say no, they ignore the groundwater, actually. So.
But not to put you on the spot, but I'm saying that you also will not be able to defend your position because you will tell me that, look, I don't know really what is the error. If you cannot tell what is the error, you cannot tell me groundwater. I cannot tell it is climate change because yesterday I showed you the rainfall did not change. So that means climate change is not the problem, groundwater is not the problem. What is the problem?
Problem is my conceptual model. I said we regulating the river water. The flow doesn't change and reach the lake. And we made a water cycle in the inland and excluding the Urmia lake from this water cycle. This is the old problem, I think. But maybe
if your assumption is correct, you have shown that it is disconnected. If it is disconnected, then groundwater may not matter.
No, I said groundwater. First of all, I talk about the surface runoff and groundwater interaction. And I said this is core of my study or core of my talk. But after that, I get the interaction between aquifer and the lake. And I bring this to, I think maybe to a mistake if I only talk about the lake and groundwater interaction. So first of all, I say the interaction.
Put the water in the river. Dr. Mugattam kindly described the issue. From the river, it goes to the groundwater and doesn't go to the lake because the bottom is empty.
So then I should be able to see that groundwater level going up as a function of time.
The first we should recharge the groundwater, and then we will be able to charge the lake. And this is a big issue.
But then it's a 20-year problem.
Then yes, more than 20.
So then the question is basically, what Jim sent something yesterday night. He found out that what LLC did, I think it was a very good article by World Bank intervention. They thought it would take, and I said, interesting paper, maybe there is the book. They thought it will never be recovered. When they built a dike, and it was recovered in 7 months, and they were thinking about 20 years. The question is to find out the bottleneck. Unless we can find out the bottleneck, we cannot address the problem. Here, all of this, I think, has very important problems, but at different time scale and different spatial scale. The question is, at what scale are we interested? If we cannot identify that scale, this is really going to be a very convoluted problem. The other problem that we have really, from yesterday, we have been keep on blaming the farmers, and none of us are farmers here. So we have to be careful, really, that even the people who are in this room are not able to answer that question. So perhaps we, at least when we go to the discussion today, ask those questions. Maybe you guys can take those questions back and let us know really what is the problem with farmers.
But we have supplementary data. So, for example, we cannot bring here. Around the Azar River, we have wells, their fluctuation is more than 17 meters per year. It says a lot of river water reach the groundwater and abstracted from the groundwater using by pipe. So, but I cannot bring all this well separately in here and say, well, what is it? I worked a lot in this plane. I had more than 50 from hydraulic point, and from hydrochemistry point of view. So we have a lot of data. So we are talking with this background. So this is not very.
Just a clarification on Professor Mogadam's presentation. You had a picture of all the dams, and who created all those dams? I said there are many dams.
The water authority makes the dam.
Is the government?
Yes, water authority.
I just want to explain something that quick Q&A is from all the people, and everybody has any data or answer. But don't worry, we can also
Now, regarding James' question, actually, as far as I know, these information are, aquifer-wide. In each aquifer, water authority has some, they call it physiometric results that can, indicate amount of water withdrawal per year. So it is not accounted well by well. It is for the entire plain.
Water balance.
Yes,
approach.
yes.
But it is not right. You cannot see the literature review to have an average long-term fluctuation from one aquifer. This is the Iranian.
Okay. And regarding to the dams, okay, we showed lots of dams over there. But for your information, I think most of them are very small dams, less than 10 meters. I think overall we have 5 big dams over there. That they are the main dams. That I believe the total capacity is about less than 2 billion. I think 1.6, something like that.
Yeah, I just was hearing some different numbers being tossed around regarding water map, and I was sort of trying to look at them and see if I could reconcile some of the differences. And one of the things that I just represented was the precipitation in the entire basin is roughly 15 billion cubic meters per year. But then I understand that the inflow into the lake is about 7, but we have that. So does that mean that the evaporation
is not 7? No, inflow to the lake is about good time it was in average about 3.5.
Okay, so there is a difference between. I was just thinking.
So
I remember
7,
some numbers.
Yes, 7 is assume the basin reaches 16 from the rain, and then also the basin is about 5 or 6 times the lake, and
Right.
then evaporates from the basin. Then 7 comes in your hand, allocate for agriculture, and to the lake. Then 1. Yes, evaporate not just lake, yes, and hold the lake. And then from 7, it should be 3 to go to the lake to have a balance. But however, in recent years, 2 is going, and 1 is used more by agriculture. And the problem of today is how to reallocate those 1 billion cubic from the new agriculture and cut it to the benefit of the lake. And it has lots of social issues to do.
Yes. Actually, unfortunately, my laptop is not I am not doing it. But as I presented yesterday, we are using SWOT model, and it is fully water balance. In average, I think the total runoff, surface runoff, is about 6.5 to 7 in normal years. We have 6.5 billion to 7 billion. It's runoff, surface runoff. About 2 billion is from groundwater, and rest is evaporated. But if you are interested to have more details, I can send it for you.
About one.
All the volume of water we're talking about is directly related to the amount of rainfall that we're getting in the basin. Is the volume of rainfall, because I've seen figures as low as 227 millimeters and you said 300 millimeters. Is this, what is
360.4 millimeters per year average. Maybe, maybe in Sahan, Mountain, it's 500. And in the low areas, it's 450. So average.
So the
It's
number
average, yeah.
for the whole basin would be.
Yeah, for the whole basin is average.
But over the lake,
Over the lake.
it is 200,
Yeah.
something like that.
But
The other factor that is we're ignoring is the fact that evaporation is a major contributor in this site. So the water losses from evaporation are what is, and we're talking of scale here, but it's considerably more than any of the water that we are requiring right now. Just straight rainfall.
No, it is not ignoring. It's not calculated by hydrology. So what their evaporation, actual evaporation in our area is 120 millimeters per year. Potential evaporation. But actual evaporation, we calculate from Penman method or other method, not ignoring. So we know about that.
So we lose a third of our rainfall.
Yeah.
Why
Yeah.
you're saying you're ignoring that?
But one thing about the well, we have data about well, how much we are pumping, and our, the farmers actually pumping 5 months, about 5 months, and also the authority measure how much they pumping, but it is not very exact.
Yeah, this is our situation.
So some wells, is for drinking water, it's pumping all the year. So maybe 12 hours per day, maybe 14 hours a day, but we have data on some of them. And this data comes from the water authority. They're doing this thing, how much you pump it, or how much, how long it pumps, 5 months, 4 months.
It's okay. I have something for us.
I don't know how to say this. I think first let me qualify that. I just want to bring in same question again and again because I think it's important. The reason is this scale is critically important. There are two things we need to separate. One is that there is scientific uncertainty. If you ask me really, I think this is a fascinating groundwater question. And that has merit, and we can work on this, do PhD thesis, and it would be a very good publication for water resources. That is a separate problem. Then I want to use science for policy implications. At that scale, really, these uncertainties are not very relevant. That part we need to recognize. Why do I say? Because we are in a place really right now here. This is one of the best technical university in the world. Green building is the place where the atmospheric science is done. There are two dominant scientists, I will not tell you the names, they disagree seriously about the source of climate change. Seriously, basically, and there are good reasons why. Because right now I do not know, even globally, nobody does, is cloud a source or a sink of heat? Is ocean a source or a sink of heat? That calculation itself can change the global change dynamics totally, scientifically. Doesn't matter. But I can tell you that, look, no matter what you tell me about those uncertainties, I know that carbon dioxide has gone up significantly over the last 100 years. That has serious implications from even first law of thermodynamics. So that means that is not the problem. I can talk about this, and next 50 years, I can do a lot of research. We can do it here also. I don't think that is the problem we're interested in. We're interested in that the lake level is going down. Why is it going down? Let's find that out and try to find an intervention rather than saying that, look, I have 10% error in groundwater, I need to put more wells. Those are very important questions. But those are scientific questions with not much relevance to the actual policy implications. Here we are in reframing business. We talked about yesterday that we want to reframe the question. Reframe for what? Reframe so that I can save this lake. And then the question is really, where is uncertainty? Is it the information or the action or the perception? My assessment right now, it is more in the action and perception than in information. Information uncertainty is there, and that will not probably go away in next 10, 15 years. I want to hear really what you think about that issue, or is that a problem really that we want to do for more scientific purposes, not for other purposes?
But, you know, the water level of lake going down is measurable. The water discharge of the rivers reduces. This is measurable. So why the discharge of rivers reduces? Why? In my opinion, it is from the because of abstraction from the groundwater. But how much is what? It needs calculation. It needs for supplementary data. It's correcting data. This is the thing I have to do.
So let us say this is true. If it is true, then what is the intervention do I need to do? So let's say that what you just said is true.
Okay, we have to back past. I said that in the past, upstream, there was no well. The people, the farmer used to from the river water. Only the downstream we had canals or some well. We have to come back to this.
Sure. Ideally true. Ideally, basically, you want to basically stop pumping, then it will stop. So I can
Even
give you-
stop pumping in the upstream. We know a plane as a sarab. We say sarab. The one mountain is Sabalam mountain. The other side is Bozgosh mountain. Two big mountains, two high mountains. The Ajichai River gets water from these two mountains. But nowadays, no water in the Ajichai because sarab plain use all the waters coming from these two mountains. But nobody says why Sarab use that, or nobody knows that the problem is from the upstream, not from the downstream. The downstream has a problem with the saline water.
Just one additional, sorry, just I want to complete this explanation. When we are talking about cutting the wells, or stopping pumping from the well, it means reducing agricultural area. So then our last discussion, what
I'm a little bit moving from the science to the policy side. What exactly the policy of the government is promoting towards the groundwater management? Is it there is an incentive structure for the extraction of groundwater, or after the government decides that the raised concern about the Urmia Lake declining, has there been any policy move that would stop extracting groundwater?
I think yesterday, Mr. Moore answered this question. So the government, they don't challenge with the people. It is difficult. This is a public, all government. But
No, that's
people,
not. I know this is a difficult process. This is not an easy process, particularly when the institutional structures are, not at place or if there is a challenge. It's much more difficult. It's difficult all over. But what exactly the government has done in recent years to address this issue, if there is any policy intervention has taken place on that front?
They are waiting the scientists, what come out from the scientists.
Okay, I tell you, just a little explanation. Actually, cutting the wells, stopping the wells is very hard, very hard. I have seen some, films that when they wanted to close the well, how the owners behave, very, unbelievable, yes. So they have started to put some meters on the well, and each owner should buy some kind of credit card, something like this. And based on those, the amount of water that is supposed to be extracted will be under control. In some of the places, it has already started, and there is I think, relatively huge amount of budget for Lake Urmia also, that they are going to put meters on the wells that at least they can somehow control of them. Actually, previously the wells were working with fuel, with fuels. Okay, it was very hard to control them, but nowadays they are connected to the electricity. So because of that, controlling of the extraction is a little bit better, and they can do it. But it takes time to have all of them on by meter. But it is already started.
That's what I wanted to do. Thank you.
Let me take one question from Andy, and then we have to break and come back with the.
I wanted to get back to Shafiq's idea of that we have to talk about the scale first. And I think in this case we are probably dealing with two different scales. The small scale, the lake is drying up. The regional scale, which is groundwater that was dropping, the farmers get salt water in their irrigation systems, and we have the global scale, and that this is a region that harbors ecological diversity for the entire globe. However, when you want to address any of those scales, I think you have to look at what is the best intervention point. And if the visibility of the lake drying up is the best intervention point, then what you need to look at is the connection between the lake, in the political now, not the scientific, the group that is fighting for the preservation of the lake. Does that group have any influence on any of the other decision-making groups? So I think you cannot just look at the scale per se, because you also have to look at what are the connections between the influence, the groups who influence policy.
Thank you. So, if you bear with me, unfortunately, let's have a 15-minute break. Think about this question, and then we have the discussion next session, and after the break, we all have discussions. So let's continue with that. Let's be back here at 11.